Hello, hey, A&P students, welcome back, welcome back. Hey, it's good to connect with you this way, as I always say, man, and just enjoy doing this, enjoy being part of your educational journey. So, hey, for me, it's Sunday. Happy Sunday to you. We're a happy day, whatever it is, whatever day that you get around to this. Chapter six. So, I don't know, a couple of weeks, 3 weeks maybe. From now, you'll be enjoying this. But I've decided, hey, we're going to rename this process here now that we got the webcam going and everything, which is a pretty cool feature. Because I mean, who doesn't want to? Let me get a pen here. I did some earth science earlier, so that's why I got green select there. So let's pick something different. Yeah, I got to rename it because since we've added the old webcam, I mean, who doesn't want to see that? And since I'm looking down at my notes so much and typing a little bit and looking all around, rarely looking, upward like I'm supposed to be if I was actually lecturing to you, we're going to have to rename it. It's no longer going to be called the video series. It's now the lecture podcast, because if you watch a podcast, especially like for me, I watch, the sports programming, and they're just talking to each other, talking to the guests, talking, to whatever, but never really actually looking at the camera. You're just kind of seeing what they're doing in their own format. It's actually a radio. Most of my radio shows that are just broadcast. So we are going to officially rename this process to the lecture podcast as opposed to video series, because video insinuates I'll be looking at the camera, which, as you know, I rarely do. As a matter of fact, you probably see the top of my head more than you do my eyes, which is not a great, because the hair is pretty thin up there at times. So, but hey, welcome back. Great to, again, connect with you. Hope you're doing well. Hope everything's going well for you. Chapter 6. So, man, if we think about it, if this is middle of October when you watch this, man, we are getting close. We are I'd be over the halfway point as far as the calendar, and a month away from Thanksgiving break. And man, once we get to Thanksgiving, that's just about it. I think we got maybe 1 week and then finals. Whoo, man, it is getting close. And just a reminder about fall. Long sleeves this morning. As you can see, it's, it's almost 11, so it's not early in the morning anymore as it was. Already gotten a couple hours worth of stuff done and got this prepared. So here we are. But a little chilly this morning. So I was sitting here thinking, man, short sleeves just not getting it done today. So yeah, broke out the long sleeves. Of course, Oklahoma, as always, football season is right around the corner. Of course, it should already be here, but with everything going on, backing everything up and trying to see what's going on. So hey, round 2 of the skin system, integumentary system. That's easy for me to say. And the first round, we talked a lot about the epidermis, and now we're going to transition into the dermis and the hypodermis, and then a little bit at the end about the variations and coloration of skin. So with that, hey, let's get started. As always, got the old notepad here, ready to go, and of course, always a little bit of water here to help the process be as smooth as possible. So with that, hey, let's get started. All right, now we will, and you can see the bottom of it right there, but we'll have to go to that because we are going to mention the word connective tissue again, and also we'll go to that picture, that image, just so you can be reminded of connective tissue. That way you don't have to go digging back into your notes. You can either rewrite stuff or just mentally familiarize yourself with what's going on. But let me close this and start our next topic. I'll move it over here, but then we're going to stop and we'll draw a little picture. Not a picture, a line to kind of show you what we're talking about. But we're going to talk about the water barrier. The water barrier, super important. I mean, and it's a pretty cool feature. It does a lot of great things for us. We don't want to check out that app right there. Don't you go away. Thank you. the water barrier. Super cool. And this is going to be kind of an outlined format, so I'm going to put my little line there so you know how to notarize it, notate it in your notes there. But it's between, no, not that one. There we go. Between, and I'm not gonna put stratum just for time, but just recognize that the word stratum should be first. Make sure I spell this right. All right, so between stratum granulosum and spinosum, and let me click out of that, and let's blow this up so we can see this, and let's move it down just a little bit, and then we'll bring back our pen. We haven't officially selected the pen. I know I grabbed the purple just to draw a line, but let's see. What am I thinking today? Any color references on my? We will get to yellow. Let's try. Yeah, let's try the yellow right here because this actually will fit. And we want a pretty thin line, and it's like we got it. So if you can just imagine, and if this doesn't show up, I'll change colors. Yeah, that's right through here. Is that water barrier line. Of course, it would go all the way over there. Is that water barrier line between granulosum and spinosum. There's a water barrier line. And now we will close that out and go back out to where we were, and then we'll move this up just a little bit, and then we'll go back to edit that, yeah, because we weren't done. Alright, so some cool features about this barrier line, and you just got to think about it. It basically separates what's above it and what's below it. I'll officially write this, but it's a pretty cool feature because everything above it doesn't get any nutrients because it can't get past. I mean, it's like a hard wall, a brick wall separating what's above and below. So let's get to, next thing. Oh, you know what? I want to do something else. So scratch this. Getting ahead of myself. Based on our, let's go a little bit bigger here so you can see this. Based on our discussion and let's get, I didn't like that yellow. That's not going to be dark enough. So let's nice blue today. You know what? No, I'm wearing, no, that'll have to because we don't have a good OU looking color. I was going to say I'm wearing OU, so why not go with that color? But this right here, that's a pretty thick line. I'll have to change that. Based on our discussions a few chapters back, mitosis, the question would be, what stage of mitosis is that cell in? And I'll pause here while you're thinking. But hopefully hands went up all over the place, all over the area that wherever you're located at, and you're screaming at your device whenever you're watching this on. Mitosis. I mean, not mitosis, metaphase. Yeah, because they're all lined up in the middle. Those centroles and those spindle fibers have drug them to the middle, and they're about to get snapped to the various edges in anaphase. So, that was fun. Now back over to our regularly scheduled broadcast. And yes, edit. So, next review type scenario. If this is a barrier that prevents water from crossing the barrier, in other words, what's below the barrier, inward in our skin, that water stays there, and the water above it, like for example, when you take a shower, okay, or you washing your hands or whatever, the water can't move across the barrier from the outside going in. So if you had that kind of barrier, what would be a type of a substance that you would use that would prevent that? What's a naturally made substance that we make, that our cells make, our bodies make, that would be a water barrier product? So again, pausing, strategically, which is a strong teacher move, as I often have. Got a lot of strong teacher moves. Well, hopefully you were screaming, raising your hand, all that good stuff. Lipids. That's right, lipids. So this water barrier, we'll butcher that right there. Got some lipids. And it also has, which you wouldn't have been able to guess, okay, insoluble proteins. So certainly lipids, and then insoluble, which obviously means water can't, not dissolved in water. Water can't affect it. These proteins. So you got this wall, okay, and then what's above it, up here, cannot come across, and what's below it can't leave. It helps with, we will officially type it, but we'll say it first. It helps with water retention. Okay. Now plants kind of do the same thing. What's the product that plants produce that enables them to at least slow down the water loss on their leaves? And hopefully you're saying, hey, that waxy cuticle covering, which also is made of, that's right, lipids. So hopefully you answered all those questions and knew the drawing, or not the drawing, but the image question as well. So just some nice little tie-ins, nice little reviews for everything. But now let's officially put that on there. Helps to retain water. So for example, for an instance, whenever someone's got too much water retention, they can just blame their water barrier and leave it there. It's not them. Just say, hey, it's not me, it's you, that kind of thing. But it helps to retain water. And then there's one more. Oh, and I've already mentioned this, but we'll officially type it now. Cells above. And when we say above, we're talking from inward to outward. So in other words, on the outside of the water barrier. Die because of no resources. And we'll click out because that's the last one of those, and then we'll go back to our picture here because you want to think about if that, and let's get a little bit darker. Oh, we've already got it one selected here. So if we redraw this line here with the blue, that you can actually see, if you think about, now you may think, okay, so because we talked about layers and cells moving up, and that's right there. Okay, but that was down here. But if you think about the cells above here, they produce their own layers within their own layers, and so therefore it's not like cells will be trying to rise up and go through the water barrier. They make their own layers up there, in these three sections here. So they're just produced outside, but they just don't receive any nutrients from the inside. And therefore, that's when you get the whole dandruff thing, the skin flaking off, and all that good stuff. So let's close that. Move this back down here. And now with that, we will transition from the epidermis, okay, and that water barrier. Now we're going down into the dermis. And just to highlight before I start typing, we're talking, I like this picture here, and we're going to use it for both the dermis and the hypodermis because it separates that epidermal layer so you can kind of see where one begins, one ends. But I'm just going to put a D here. That's the dermis, and of course later on we're going to get to this section, and that's the hypodermis. And then we'll close this up, and let's move all this over just a little bit, and we will start our next topic. And I'm going to move it over just a bit because some of these lines are kind of long. But the dermis. Yeah, I'm sure you've learned by now. Let me finish typing because you never know when I'm going to go back and fix a word. Let me finish typing and then start writing. But I'm sure you've already picked up on that. All right, so again, outline notation symbol there, which is again strong teacher move right there, which is what I'm all about. Connective tissue, and after done here, we will, okay, connective tissue layer. So all of this connective tissue, and just as I promised, so you can see, let's go up here. This is what I dragged into the last series, just so you can see connective tissue. But the whole idea is just connection. You know, connecting what's above to what's below, connecting it to the, as it says, organs, and then support, protection. Lots of blood vessels, which is we're also going to notate that as well. So that's connective tissue. It's just a layer designed to support and to provide structure, protection, all that good stuff. So yes, edit that. Next line. Okay, we got a range here. And a little semicolon there. And what I mean by range is that in different parts of the body, the dermal tissue, the dermis tissue layer is thinner or thicker. So in the eyelids, where it's the thinnest, we're talking 0.2 millimeters, so really, really, really thin. And then in the thick skin, so like in the palm of your hands, soles of your feet, but I'm not going to put my foot up on the desk so you can see that would not be a strong teacher move right there. Wasn't it 4? Yep. 4 millimeters. So pretty thick skin right there. But that's, you can feel and I'm going to reach down. You can feel that in the palm of your hands, feel that as well. All right, and so next line. Let's see, consists of collagen, and of course that's probably something that we could have guessed, considering that's one of the products used to kind of fill in those areas, especially eyes, around the eyes and eyelids and stuff. And it's got elastic and reticular fibers, so really stretchy, really reinforcement. Again, it's just highlighting the fact that it's support, it's protection, it's framework, it's all that stuff with those particular ones. And then there was one more, fibroblast. And of course, you remember anytime something's got the word blast at the end of it like that, that means it's a cell that produces the fibers. So if you think back or go back and look, the fibroblast is what's going to be one of the things that produces the elastic and reticular fibers. Those are the basic production cells. All right, next one. Okay. Lots of blood vessels, and we saw that in our connective tissue. Lots of blood vessels and sweat glands. So all those things, sebaceous glands, and there's one more I was thinking, the nerve endings, yeah. Now the thing to remember about all these is all of these have a connection, a relationship with the surface of the skin, sweat glands, sebaceous glands, and then those have to produce it on the outside, but they're rooted. And what we mean by that, let's close this and get the pen back up here, like this hair follicle here. Okay, it does reach the surface and above, but it's rooted. Okay, these glands here, they do reach the surface, but they're rooted in the dermis layer. And that's what we mean by that they're there. We have lots of them. The roots are there, but they may reach up above, but the roots or the body of them are in there. So close this, come back to this. super smooth on the skills, on the teacher skills right there. Clicking things, clicking out of things, clicking into new things. Oh man, it's all going good today. Hair follicles, as I just mentioned. Oh, that didn't spell right. From the get-go, hair follicles, and if you're going to have hair follicles, you got to have the smooth muscle that controls. And I'm just going to put, I'll go ahead and put follicle, why not? It's Sunday. The hair follicle. So, and goosebumps as well. And goosebumps as well. So that muscle that controls, makes those goosebumps, makes the hair stand up, lay back down, that kind of stuff. It's got to have that in there as well. So that's the dermis. And again, we're talking this section right here. And now we'll close out of this. Didn't mean to do that. And we're going to slide up just a little bit here. And start a new box here. And we're going to just go right below it here. Now we're talking hypodermis. No, no. And again, little outline notation there. Hypodermis, and of course this is the answer to the trivia question. Why is a hypodermic needle called a hypodermic needle? And you got most of you are in the nursing field, or quite a few of you are, so you can have already made this connection. Because it's got to reach the hypodermis. That's where the medicine is injected. We're saying it now. We'll officially type it up here, notate it. But that's where if you get injected medicine, that's the layer it has to reach to, and not have to reach to, but that's the layer it reaches, because that's the most, that's the layer that absorbs the quickest. It's very vascular, takes that medicine right in and gets it right to where it needs to be quickly. So hypodermis, subcutaneous, I wanted to put the O first there. Oh, yeah, there I am. Tissue, not two eyes. There we go. And pads the body. And the reason why it pads the body it's got a fat layer. Oh, I didn't do my notation there. And that's this yellow stuff right here. That yellow stuff there. If once we get to dissection, or if you've ever been a part of dissection, when you open something up, you can literally see that fat layer. Now you can see fat, but it's not because it's the hypodermis layer. But you have probably seen what that looks like, and that's what you're seeing there. That's that yellow stuff right there. Now this fat layer, now I'm gonna go two lines, because actually what we're gonna type now is under fat layer. So whether you just move over a little bit or maybe do an A underneath, but these are part of the fat layer. It's an energy reserve. Boy, that doesn't look right at all. I think it is though. But anyway, you'll fix yours if it's not. But again, man, I need this whiteboard, this Microsoft whiteboard, to get that spell check in there. I need that red line to let me know that something isn't right sometimes. Thermal insulation. And in women, it's 8%. thicker in women. And I think we're just going to leave that one alone and let that one just stand for itself, stand by itself there. We're not going to touch that. All right. And then, of course, we mentioned this already. Now we're back to just a new line. Drugs are injected here. It's highly vascular. And that's a word. It's actually a, oh, I left out my C there. Highly vascular, and that just means it's got the processes to absorb it and then get it moving to where it needs to. And that's these blood vessels for the most part are part of that. But like the word vascular, when you're talking about plants, it refers to the xylem and phloem. And the xylem moves the water from the roots up to the tree, and then the phloem tubes bring the sugars that the plants, that the leaves make, photosynthesis, down to the rest of the plant. And there's one more there. Oh yeah, absorbs quickly. All right, so that is hypodermis. The hypodermis layer there. So, boy, we just only got one more section. This seemed like it's been a quick one, but I think maybe it has been. So, but we got one more section here, and it's not a real long one either. So we're almost done here for today. Now, as you probably have noticed, as you talk to people, around people, that there is a variation in the coloration of skin. And there's reasons for that. So let's talk about variations in skin color. Now think about, we're gonna compare this to size of organisms. So let's think about an elephant and think about a mouse. If you can picture those in your mind, please. I will pause while you conjure up those images. There you go, dramatic pause, strong teacher move like there. Now, the question would be, when you're thinking of the elephant and the mouse, are the elephant cells larger than the mouse cells? And the answer is no. The elephant just produces more cells. Okay, it's got the same size, but there's obviously a great difference in the size of the organism. The elephant just has a lot more cells. Okay, when we think of variations in skin color, we're going to think that same concept. The cells aren't any different. Okay, just the melanin is produced at a higher or lower concentration. And there's one other factor that we're going to introduce as well. But our first note here, the melanocytes produces the melanin. Okay, that's our first notation right there. And now let's talk about the variation. The variations, no, I didn't have there. It's a product of two factors. Okay, factor one is I'm just going to simplify this down. Oh, I didn't do my notation there. Sorry about that. Factor one is melanin spread. Factor two is melanin breakdown. And what I mean by that is within skin, if the melanin is really spread out, okay, that produces a darker color. If it's more clumped together, that produces a lighter color. Factor 2, the melanin breaks down. And if it breaks down quickly, again, you can produce a lighter color. And if it breaks down slowly, then you have a darker color. So when you put those two factors together, if someone is very, very light skinned, almost like maybe the background here at this whiteboard, or just light skinned, then that means that their melanin is very clumped together and it breaks down quickly. Okay, darker skin, the melanin is spread out more. Okay, and the melanin breaks down slowly. But I will put those. I just wanted to say them first, and then I will equals melanin clumping and quickly. And of course, then the opposite of that, so darker skin equals, and how about that equal sign right there? That's a strong teaching move right there. Melanin spreading out and melanin breaking down slowly. And it's a gradient. So it isn't just one camp or another camp. I mean, we've got all kinds of variations in skin color, and so it's just a gradient. And you can have, you can have it spread out, be it breaks down a little bit quicker than somebody else, and so it's just all kinds of, just a wide range of of how quickly or how much spread out it could be. So that is variations in skin color. Oh, I didn't mean to click on that. And so that, ladies and gentlemen, we do have one gentleman in the class, so I got to throw him in there. Hey, thank you. We're going to start to wrap this up here. Anyway, hope you enjoyed it. That's probably more notes than pictures, but important stuff. Hey, I mean, how can you be in the fields that you guys are going to be in and not understand the skin and all the things that are associated with it? So, hey, with that, enjoy the rest of your day. And as always, hey, I hope everything's going well with you. Hope you are well. Hope your family is well. Everyone around you is well, physically, mentally, all that stuff. Appreciate you guys doing this. Love you guys. And hey, with that, go enjoy the rest of your day or evening, whichever it might be. And until next time, we will say goodbye.